Today we're going to be discussing how to interpret function notation. So last time we went over what is a function, how to talk about the domain of functions, that type of thing. And today we're going to be talking about how do we use the language of functions. So in particular, the big idea is that you will see some sort of function, most commonly named f, but in theory any letter. And then in parentheses, it's going to give you what that input of the function is. So the way that you would read this notation is that f is the name of the function. And then whatever is in parentheses, in this case x, is the input of the function. And then this whole phrase is going to equal the output of the function, most commonly y. So f of x you can often in your head translate to y, so it's always going to be the output of the function. That's really the big idea, but let's continue to look into this translation. And really this section is going to feel like you're learning the language of mathematics and how we talk about the language of mathematics. So oftentimes you may have such that, maybe the original equation is y equals 3x plus 1, but then the way we're going to rewrite that is we're going to replace y with the function notation f of x. That's how you actually read that. F of x to say that this is a function where that's called f, where the input is x, and x is your input there, and you read that as f of x. That's how you read it off in English. Or similarly, you can always rename it some other letter. There's no law that says it has to be f. You could have a different function where instead of calling it f of x, you call it h of x. So now we're calling the function h. But the key part of the notation that stays the same is that you indicate this is our input, and then this is the input letter that's used in the actual function as well. So the first letter always gives you the name of the function. Let me actually do that in the same color. So you always do the name of the function, and then parentheses, the input of the function. That's always how you read it. And the way, again, that you read it out loud is f of x, h of x, g of x, whatever is that letter. G of x would look like this. So that would be a function called g with an input of x. G of x would be how you read that off. So let's take a look at some more notation and how we actually interpret this. So if you have something like f of 3 equals 5, remember in this f of x notation, the 3 has taken the place of the x. So in particular, that means when x equals 3, when your input is 3, the output y equals 5. So that would be the ordered pair 3, 5. So again, wherever that input is, in this case 3, that's taking the place of x, so that's telling you when x is 3. And then the output is this 5, so that's telling you the output is 5. That's really where those numbers come from. And then the function also happens to be called f, since that is that first letter out front, so that's the name of the function. You also could have a function represented by a graph, and it would be the same idea. So in this case, if they're calling this graph f of x, that means x is our input. The function is called f, which is the most common name of the function. And if they're looking for f of -1, that's looking for when the input is -1. So on our graph, I would go over to -1 being the input, trace it up, and then I would trace that over to give us that when x is -1, it looks like y is 2. So that tells us that it equals 2, because when x is negative 1, y is equal to 2. So that actual ordered pair would be negative 1, comma 2. Before I keep moving on, go ahead and pause your video and see if you can evaluate f of, let's say, 0. So on your graph, f of 0 means x is equal to 0 because that's taking place in that f of x notation. The 0 has taken place of x, so that's saying on your graph go to x is 0, trace it down, and it looks like y is equal to negative 2 in that case. So that would be the point 0 comma negative 2 that exists on the graph. Instead of giving you a graph, you could be given a table. So let's say from a table you want to evaluate f of 2. Well, that's telling you that x is equal to 2 and you want to figure out f of x, aka y. So on your table you go over to when x is 2, and it looks like that f of 2 is equal to 21. So the point 221 is depicted in this table. Similarly, see if you can evaluate f of 9 according to this table. F of 9 means that x is equal to 9, so it looks like f of 9 is 69 in this case. Occasionally the question is also asked backwards, and it's asking what is x when f of x is equal to 94. In that case, you would be going over to 94 in the f of x row, aka the y value is 94, and then tracing back that the x value would have to be 4. So x equals 4 would correspond to that for the point 4 comma 94. So keep in mind, if the x in f of x has been replaced, that is your x value. If f of x still has an x there and it says equals a number, then that's your y value. That's your output that they gave you. Which brings us here. So let's do a similar sort of idea. So the first thing they ask us is to evaluate f of 1, and then they ask us for what values does f of x equal 1. So go ahead and pause your video and see if you can figure this out, and then we'll go over it. So for the first part, f of 1, keep in mind that means x is equal to 1 because in f of x language, the x has been replaced by a 1. So on our graph, we go over to 1, trace up and over, and it looks like y is 2 there. So the point 1 comma 2 is on this graph. Similarly, if it asks for what values of x does f of x equal 1, now x is still an unknown, x is still a variable. So really they gave us that y is 1 this time, and they need us to find x. So I'm going to go over to 1 on the y, trace it over, trace it down, and it looks like x is equal to 4 for the point 4 comma 1. You can also be given information instead in a just plain function. So what does that mean? So if they ask for f of 0, recall this means x needs to equal 0. So if you're looking for f of 0, what you want to do is rewrite the function, but everywhere you see an x, you replace it with a 0. Then you go ahead and solve according to order of operations. So 2 times 0 is 0, plus 1 is going to give us 1. So we just confirm that the point 0 comma 1 is on this graph. Similarly, if we want to find f of negative 1, that means everywhere we see an x in the equation, we're going to replace him with negative 1. And I'm just going to illustrate that again with colors here. So again, remember the equation was f of x is equal to 2x plus 1. If you want to find f of negative 1, that means everywhere you see an x, replace him with a negative 1. Then solve according to order of operations. 2 times negative 1 is negative 1. Negative 1 plus 1 is 0. So we just confirmed that the point negative 1 comma 0 exists on this graph. For this last one, go ahead and see if you can evaluate f of 2 similarly. So to find f of 2, we're going to, everywhere we see an x, replace him with a 2, and then we simplify according to order of operations. So 2 times 2 gets us 4, and then 4 plus 1 gets us 5. So we know we have the point 2, 5. And if they just want the f of x value, they're just looking for that y value corresponding with that x value. And keep in mind, our functions don't have to be called f. They also could be called r, g, whatever. So in this case, it's called r. So r of x, square root of x plus 1. And I'm going to, again, kind of differentiate the x with the color here. So if they're wanting you to find r of 0, what is that asking you to do? That's asking you everywhere you see an x, replace it with a 0. And then evaluate accordingly. So the square root of 0 plus 1 would just be the square root of 0 plus 1 is 1, square root of 1 is 1. So we just confirmed the point 0, 1 exists on this graph. For the next ones, we again want to do a similar sort of process. So if we're evaluating r of 3, that means everywhere we see an x, we'll replace it with 3. If we're evaluating r of 8, that means everywhere we see an x, we replace them with an 8. And then follow order of operations accordingly. So r of 3 means that we replaced everywhere we saw an x with a 3, and then we're going to simplify. 3 plus 1 is 4, square root of 4 is 2. 8 plus 1 is 9, square root of 9 is 3. So we just confirmed that the points 3, 2 also exist on this graph, and the point 8, 3 also exists on this graph. So in short, function notation, what you really need to keep in mind is how to translate between f of x and y. So in particular, sort of big idea, if you see f of x equals a number, that number it equals is y. So if you have f of x equals 3, that means that you were given y is 3, find x. If instead you have f of 3 equals y, or whatever, or if that's what you're just looking for, then that means x equals 3. We don't know y yet. So that's the big translation you want to keep in mind, and the way that you can keep that straight is if x is still an unknown variable, that means that's what you have to find. If x has been replaced by a number, such as 3 or even an algebraic phrase, that means that you were given that x and that you instead need to find the output.